Hey there, this is a tutorial on creating inscribed regular polygons in a circle of radius 1 using GeoGebra. So first thing we want is a circle. However, we need to make sure that its radius is 1. So the way I do that is in the upper right, if you click the gear, show the grid, major grid lines, and then each one of these squares has sides 1 unit. So if I put the center of my circle at one of the intersection points and then just go horizontal to the next point, that's 1 unit. And then from here, what we can do is just go back to the gear and no grid. So get rid of the grid. But from A to B is 1 unit. And so now what we want to do is think about what the central angle of this polygon would be. And so the central angle is the angle that goes from a point on the circle to the center, and then from the center to some other point on the circle. So CAB is a central angle of this circle. But for regular polygons, there's a special value that you need for the central angle of each polygon that depends on the number of sides. So let's say we want a regular octagon. I can scroll down to where it says polygons, and then this is the regular polygon button, and click one point, click again, and it's asking for the number of vertices. One octagon has 8, so there's a regular octagon. Regular meaning all of the sides are congruent, which we can check with in the measure section. On to the third one, measures a distance or length. All of these sides are going to work out to be the same amount. And that's one of the properties of a regular polygon. So the problem with this regular octagon is that the radius, well, one, it's not inscribed in the circle, and two, if it was, we wouldn't know if the radius is 1. So what we do is start out with the circle of radius 1 and then create the polygon inside the circle. But we need a central angle measure. One way to find that would be to connect opposite vertices to find the center of this regular octagon. And so this is the center, and we can put a point there. And so now, if we measure from H to L to G, we'd see that this central angle is 45 degrees. And you can keep doing that all the way around, and you'd get 45 for all of them. So what we need is, I'm going to delete this first. What we need is a circle whose radius is 1 and a regular octagon inscribed in it. So we would need this angle to be 45 degrees. Let's measure to see what it is. 49.87. Okay, that's not going to cut it. So, lucky for us, there is a tool that will give us the exact angle that we need. So let's get rid of a few more things. Get rid of C and that extra point D. In the second button in the measure section allows you to create an angle with a given size. So now if I connect B to A, and 45 is the default value that comes up, this will allow me to create an angle that's 45 degrees. So there's my 45 degree. That would be a central angle. And one neat trick that I figured out here is that if you go to the regular polygon tool and then just click your first B, then click your next B, that will create the side of one of the sides of the octagon. Again, we need 8 vertices. Click OK, and there it is. So from here, there's a couple things that we'd be interested in. One of those would be the perimeter. You can find perimeter by clicking the distance or length button, then click the shape. Perimeter of poly 1, 6.12. And the other value of interest would be the area. Click the area button. Click the polygon. Area of poly 1 is 2.83. And finally, one last area of interest in this regular polygon would be what these interior angle measures are, from D to E to F. And that's 135. And when you have a regular polygon, not only do all of the angles or all of the sides have the same measure, but also all of these interior angles have the same measure as well. So I'm zooming in right now, and I'm going to grab the move button to center this. And you can also move these labels around. And that will conclude this video.